Now, in deriving the kinematic equations, this is what we're going to do. We are going to take equation number 1 and then equation number 2. And if we don't remember what equation number 1 looks like, here's equation number 1. So right down here. Okay. And we are going to get rid of this average velocity by using equation number 2. And we're just going to replace the average velocities with this side of the equation. So we're going to take the right sides of both equation number 1 and equation number 2 and equate them. That's all we're doing. So we start off with xf minus x initial divided by t equals to the initial velocity in the x direction plus the final velocity in the x direction divided by 2. This is our fourth equation, but now this is our first kinematic equation. It doesn't have to be, but this is our first kinematic equation. Based on what you're looking for and based on what you know, you can calculate any one of these variables. So if you know the time, let's say you know the time here. Okay. So you know the time. Let's say you know the initial velocity and the final velocity. You can calculate the displacement here. Okay. That's if you know those things. So let's just write this in a different form. Let's call this 4a. So that means we can have a 4b. And let me just double check my equation numbers. Okay. Very good. So we can say that we have xf minus x initial equals to v initial times x plus v final times x divided by 2. Oh, and remember that this is divided by t. Now we want to solve for the displacement in the x direction by itself. How do we do that? We use the multiplication principle of equality, which means that if we multiply one side by t, we have to multiply the opposite side or the other side by t. And we know that t over t is identical to 1, and this implies, no, I don't want to say implies, I'm going to say therefore, we have xf minus x initial equaling to the initial velocity in the x direction plus the final velocity in the x direction multiplied by t divided by 2. This is going to be equation 4b. And I'll just circle that like so. Hopefully that doesn't freak you out too much. And let's just go ahead and put a little box around this. All right. So that's that particular equation. There we go. So we'll use that equation. Now what we're saying is we can find the displacement as long as we know the initial velocity in the x direction and the final velocity in the x direction and the time it takes for this event to take place. That's all we're saying. The end. You have the tools to measure what's on the right side. And since you have the tools to measure what's on the right side, we know that the entire right side represents the displacement in the x direction. That's what this equation is saying. And yes, it is beautiful. Okay. Now, that's 4b. Let's go ahead, and what we want to do is we want to use 4b, and we want to use equation number 3 to come up with the next equation. You know what? Let's just start with equation number 3 to come up with our next kinematic equation. Okay, so equation number 3. Just give myself another piece of paper. So remember, equation number 3 is written like this. A sub x And that's our constant velocity. It's just equal to the final velocity in the x direction minus the initial velocity in the x direction, all divided by t. So let's solve for this is a kinematic equation all by itself, just to be honest with you. But I want to rewrite it, okay? And yes, we can calculate the average, or not the average, but the constant acceleration provided we know the final velocity, the initial velocity, and the time of flight. In other words, we have two radar guns, one checking the initial velocity, one's checking the final velocity, and we have a stopwatch. Bam. We can calculate it. Let's multiply both sides by t. And what do we end up with? Well, since t over t is identical to 1, this implies that we can write a sub x times t equals to vfx minus v initial x. Look at this stuff up here that I have. It should be an x. And we multiply, well, the t is gone, okay? So we're solving for the final velocity in the x direction. I may have failed to mention this, but that's what we're solving for. So let's say that if we're solving for that, we have to use the addition principle of equality and add the initial velocity in the x direction to both sides. When you do that, you know that the initial velocity in the x direction, the negative, plus the positive, is just equal to what? 0 is correct. Since that is the case, this implies that we can write v initial, the initial velocity in the x direction, plus the acceleration in the x direction, times time, equals to our final velocity in the x direction. Now, we don't typically write what we're looking for on the right-hand side. We write what we're looking for on the left-hand side. And we write what we know on the right-hand side, okay? So, therefore, we can write v final in the x direction equals to the initial velocity in the x direction plus the product of the constant acceleration in the x direction and time. This is going to be equation number 5. And remember, we're deriving all of this stuff from axiomatic principles. So now at this point, what I would like to do, or in the next video, what I would like to do is I would like to derive our final equation, and it's going to connect 4b to 5. Again, 4b right here to 5. And that's right here in this orange box.